Hello, all my dear students. Welcome to Sri Jain's Rank Zone classes. My name is Ajay Gulati, and I'm your friend and mentor for the mathematics portion that is we also call as quantitative aptitude. Dear students, as you can see on your screen, we'll be discussing the chapter permutations and combinations today. Now, dear students, we have, let's say, first of all, this is our class 03 for permutation and combination. Now, what I was saying, now what topic we are going to discuss. See, the topic we are going to discuss is selection. Selection of selection out of n things. Out of n things. This is an interesting topic. You will enjoy it, and eventually the answers will become very easy in this one. Suppose I say, suppose we have n things. Or to suppose we have n things. Number of ways of selecting one thing. Number of ways of selecting one thing will be how many? That will be NC1. Number of ways of selecting two things will be what? Will be NC2. Similarly, number of ways of selecting three things will be NC3. So on, if I go, number of ways of selecting n things will be how much? They will be NCN. Now this whole is what? Number of ways of selecting at least one thing out of n things. Number of ways of selecting at least one thing out of n things. Number of ways of selecting at least one thing out of n things will be this. This is what? This is NC1 plus NC0, sorry, NC2 plus NC3 plus NC4 up to NCN. This is what? This is equal to 2 raised to power n minus 1. I will show you how. I will show you how. See, let me take a red pen for a minute. If to this, if to this group, I add one more thing, number of ways of selecting zero things. Number of ways of selecting zero things will be NC0. Okay. Now this, see, in this, here I am taking all these cases from 0, 1, 2, 3 up to n. Number of ways of selecting at least one thing, I am taking 1 to n. This value I am saying is 2 raised to power n minus 1. I will show you, I will explain you how it comes. See, dear friend, this is all possible selections, all possible selections, all possible selections out of n things. Out of n things, that is what? NC0 plus NC1 plus NC2 plus NC3 up to NCN. NC0, NC1, NC2, NC3 up to NCN. This will be what? This will be 2 raised to power n. This will be 2 raised to power n. See, dear students, how come? How is this coming? I'll show you. Example, suppose I say, to explain you this concept, suppose I say Draupadi wishes to invite to invite her husbands for a dinner at home. In how many ways in how many ways invite can she before this might be a typical one. Before Draupadi, let me take a easy one. Just give me a second. Just give me a second here, students. See, suppose I say the switchboard in my room, the electronic switchboard in my room, the electrical switchboard in my room has three switches, has three switches for three tube lights, for three tube lights. Okay. In how many ways can I set the light in my room? The light in my room. I will show this thing to you in great detail. See, I have three switches. I have three switches. Okay, three switches. For the first switch, I have two options. Okay, three switches. Let's say for the first switch, I have two options. These are on or off. Okay, on or off. Whether it is on, whether it is off. For the second switch, I have again two options, whether it is on or off. For the third switch, again I have two options, whether it is on or off. So total how many options? Total is for the first switch I have two options, for the second switch I have two options, for the third switch I have two options. So that gives me total eight options. I'll show it to you. Eight options. Look, these are the total eight options. See how I let me show it to you in detail. Just give me a second. See, what I wish to do is right now what I'm explaining you precisely is in how many ways can I see on and off, on and off, on and off. It's like this. In how many ways can I need to write one more thing so that I may correlate the two things. See, three switches. I have told you total eight options. For every switch, you can put on or off, on off. See, the first switch I can make it on or off. For second switch, I can make it on or off. For third switch, also I can make it on or off. So I have eight options. Now, let's say zero switches on. Now I'm showing it to you by different methods. Zero switches on. Zero switches on. In how many ways out of three switches can I turn on zero switches? That will be 3C0. I have already told you what is NC0. NC0 is 1. Okay, then one switch on, that will be 3C1. That is NC1 is N 3. Okay, two switches on, that is 3C2. But if you look carefully, this 3C2 is what? Like 3C3 minus 1. This is NCN minus 1. This will be again 3. Last, all three switches on. All three switches on. This will be how much? All three switches on will be 3C3. 3C3 will be 1. Okay, this is 3, this is 1. So total how many ways? Total is 1 plus 3 plus 3, 8 ways. 1 plus 3 plus 3 plus 1, 8 ways. So this is what I was saying. Okay, that is, see, selecting 0 out of 3 switches, selecting 1 out of 3 switches, selecting 2 out of 3 switches, selecting 3 out of 3 switches is 8, or this 8 is actually 2 raised to power 3. This is what I intend to explain to you. Okay, the all the possible arrangement out of 3 switches is 3C0 plus 3C1 plus 3C2 plus 3C3, and this will add up to give you 8. And this is another way of showing this is 8y. First switch you can put it on or off, second switch you can put it on or off, third switch you can put it on or off. This is 8 options. Now let me take a classic question of this. Draupadi wishes to invite one or more. This was actually the question, but I was thinking of explaining some concept to you, that's why I modified the question. Draupadi wishes to invite one or more of her husbands for a dinner at home. To invite one or more of her husbands for a dinner at home. In how many ways can she do so? In how many ways can she do so? See, she has five husbands: Yudhishthir, Bhim, Nakul, Bhim, Arjun, Nakul, Sahadev. Okay. For the first option, for the first person, she has two options: whether she will call him or not. For the second option, she will also have two. She has two options: whether she will call him or not. That is her choice. Again, for the third person, Arjun also, either Draupadi will call him or she won't call him. Then for two, then again two. Getting this thing. So this is how many ways? This is 32 ways. These are all possible ways. All possible ways. That is 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. This is equal to what? 32. But she will call, but she will call at least one. She will call at least one. So rejecting rejecting the case in which she calls, so rejecting the one case in which he will call none. So your answer will be what? 32 minus 1, that is 31. This is the answer. Okay. These are all the possible ways, that is 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, 32. But she will call at least one. But she will call at least one husband. At least one husband. So what will happen? This is 5C1, 5C2, 5C3, 5C4, 5C5. This will be what? 2 raised to power 5 minus 1. 2 raised to power 5 minus 1 is what? 31. Okay. So now the thing which I need to explain is to you is total number of ways, total number of selections out of n different things. Total number of selections out of n different things is 2 raised to power n. That is nc0 plus nc1 plus nc2 plus nc3 3 plus NC4 so on up to NCN. That is 2 raised to power n. This is one case. Number of selections with at least one thing selected. With at least one thing selected is what? That is 2 raised to power n minus 1. That is NC1, NC2, NC3, so on up to NCN. That is equal to 2 raised to power n. This one case comes over here and gets subtracted, minus NC0, or this is equal to 2 raised to power n minus 1. NC0 is 1. You already know this. Okay, dear students, clear to everyone? Fine. You can have a look at it. Before I proceed further, let me take one question in this page. See, the question we have right now is Ram has 10 friends. In how many ways can he invite one or more of them at dinner? See, directly. One or more out of 10. This is what this is. This will be 1 or more out of 10 will be 2 raised to power 10 minus 1. That is 1024 minus 1 or 1023. Got it? Simple, plain logic. Fine. Clear to everyone? Fine. See, dear friends, so far what we have been discussing is number of ways of selection of things out of n things. These n things are n distinct things. Okay, let me write it. These are n distinct things. N distinct things out of n distinct things. Now we will take selection from similar things. Selection from similar things. Selection from n similar things. From n similar things. See, dear friends, similar things all are alike. Suppose I say I have 5 bananas. 5 bananas. Or let's say rather I should say five. Should I say cricket balls? 5 cricket balls. 5 table tennis balls. 5 table tennis balls. I ask you to select two. Select two. So it is only one way. It is only one way. This is only one way because all are alike. All are alike. So the thing is, when you have n similar things, you want to select r things. Okay. Selecting, suppose, first of all, suppose I say, suppose r is a number, r is less than n. Suppose r is less than n, number of ways of selecting r things are things out of n similar things, out of n similar things. Number of ways of selecting are things out of n similar things is what? Only one way. Okay, clear. All the things are same, you just have to count r and you have to pick them. So this is only one way. Clear to you, dear students? Fine. Now next I write number of ways of selecting any number of things, of selecting any number of things. Let me write first number of ways of selecting at least one thing, at least one thing out of n similar things is actually n. See, how come? Anyways, suppose you have five things. Out of those five things, I ask you to select one thing. It is only one way. Pick anyone. If I ask you to select two things, it is also one way. You have to pick any two tennis balls, table tennis balls. You can't differentiate between the balls. Na? You just blindsidedly put your hand in a bucket. Out of five things, you pull two books out. You pull two balls out. That will be the same thing. If I ask you to pick three, then also you will be blindsided. Put your hand in a bucket or in a mug which contains five balls. You will pick out three. So total number of ways is n. Why n? For one thing also one way, for two thing also one way, for three thing also one way, for one four thing also one way, and for five thing also one way. Next, number of ways of selecting any number of things, selecting any number of things, any number of things out of n things. That will be n plus 1. Here you have a choice for 0 also. This one is for 0. This one is for 0. Here, dear students. Fine. Suppose I take an example over here. One thing is clear to everyone. Okay. So now suppose I say number of ways of selecting, number of possible selections of selecting things out of this. I will show you via question. Okay. Just give me a second. I will show you via question. Here we have a very good question. A bag contains three similar books, four similar coins, and five similar pens. How many selection of object can be found by taking at least one thing from the bag? See, it's like I have something in my bag. I tell my daughter that I have bought something for you, some gifts for you. She will come to me, Papa, I need at least one gift today. She'll say, Papa, I need at least one thing today. I give me some gift. If I don't give her anything, she will feel very dejected or she will be angry. Fine. When she will, I just want her not to be angry. I just want to make her happy. So what I'll do, I will give her at least one thing. Okay. Now let's say all the possible ways in which I can give her the things. See, we have three similar books. It's my choice whether I give her a book or not. Okay. Or I may give her more than one book. So how many choices I have? I have 3 plus 1 choices for the books. How come 3 plus 1 choices? Either I can give him 0 books, okay, or I can give her one book, or I can give her two book, or I can give her three books. So 3 is for 3 and 1 is for 0 books. Okay. Very similarly, for four similar coins, what I'll do, either I can give her one, two, three, or four coins, or I will give her no coin. For the 0 coin, this is one. Similarly, for five similar pens, I have five ways. One, two, three, four, five. I can give her any number of pens, or I can give her now no pen. This is one thing. But after this, If I, all these cases include a choice when I give her nothing, but out of these three things, if I give her nothing, she will be angry. So I'll have to subtract one way where I am giving her nothing. This particular one. So this is like 4 into 5 into 6 minus 1. 4 into 5 into 6 minus 1. I'm sure this must be clear to you so far. Clear? 4 into 5 into 6 minus 1. Options, let us check. 20 into 6, 120 minus 1 or 119 ways. You can have a look over it. Clear? So, my dear students, today we have done almost every possible question pertaining to this exercise. And I hope if you practice these questions, you will be easily able to master your topic permutation and combination. And the best thing about this permutation combination is the questions are might appear to be tough, but they are very small. You can solve them in very limited time. So make sure you practice them by writing, because it will take very little time to practice. And once you become a champion of these questions, you will be very easily able to solve these questions in your exam in very limited amount of time, which will give you more time to solve further questions. So with this, I will take your leave by saying, please practice as much as you can. Just by watching the videos, you won't be able to solve them in your exam. Practice as much as you can. Practice by writing. All the very best, dear students. Crack your exam. Bye bye. Take care.